nucleophilic acyl substitution is typical associated to carboxylic acid and acid derivatives. We're going to focus on this reaction for this chapter. Before we discuss nucleophilic acyl substitution in detail, I'd like us to kind of briefly review about nucleophilic addition reaction that typically occurs with aldehydes and ketones. So a nucleophile could attack on the carbonyl carbon, and the pi electron between carbon and oxygen is shifted over to the orbital of oxygen, we generate a tetrahedral reaction intermediate. After protonation, a product is generated. Under these circumstances, the reaction is generally referred to as the nucleophilic addition reaction. We're adding the nucleophile onto the carbonyl carbon. The nucleophilic acyl substitution reaction occurs when a carboxylic acid or its derivative is reacting with a nucleophile, and a nucleophile attacks on the carbonyl carbon first, but eventually the leaving group is removed. A nucleophile is substituting the leaving group. The reaction is typically undergoes a two-step mechanism, but under the circumstances, eventually your nucleophile is substituting the leaving group. So the reaction is referred to as nucleophilic acyl substitution reaction. We write nucleophilic acyl substitution as abbreviation. Okay, so what we're going to do next is we're going to look at the scope of the reaction. Okay, so nucleophilic acyl substitution reaction could occur with many different carboxylic acid and derivatives, including acid halide, anhydride, ester, amide, and carboxylic acid, and often is could also be carboxylate. Okay, so and the nucleophile include the following. Okay, and the nucleophile could be oxygen-based nucleophile, hydroxide, water, alkoxide. Nucleophile could be nitrogen-based nucleophile, and there could be also be hydride or alkylide nucleophile. And when you react a acid derivative with a hydroxide or water, and essentially we're generating a carboxylic acid, we call the reaction as hydrolysis. And when we react a carboxylic acid and derivative with an amine nucleophile, we're generating an amide. The reaction is generally referred to as the ammonolysis. And when we react carboxylic acid or derivative with an alkoxide nucleophile, we're generating a different ester. Okay, we call the reaction as alcoholysis. Okay, if your starting material is an ester, it's also called transesterification reaction. And the reduction reaction could generate various different products, so I didn't really identify what product. We're going to look at different examples. And when you have a nucleophile that is alkylide, essentially you're converting your carboxylic acid or its derivative into the corresponding ketone. Okay, and the reaction we're going to be focusing on are the Grignard substitution reaction. So many of the reactions are summarized in section 17.5 to 8. In your textbook, these materials are generally presented in the functional group of the starting material. So there is a section of acid halide, a section of anhydride, ester, and amide. When I'm discussing these topics, I'm discussing the topics with the corresponding product that's generated. So we're going to have a section on hydrolysis and a section on ammonolysis and so on.